All right, hey, chemistry. Here we are again. I am going to be teaching you today on this recording part of section 12B, which deals with calculating the concentration of solutions. So how much solute you have dissolved in your solvent. And there are several different ways that this is expressed. In chemistry, it's generally one of two ways. I'm going to show you a quick example just in labeling of products that you might buy at the grocery store. And that's a little bit different than what we actually use in actual chemistry problems. I'm going to give you, show you a couple of examples of those. And then it's mainly going to be number crunching to determine something called molarity. So I'm going to pull up my presentation now. Again, we'll go through the PowerPoint on concentration. So when we look at the idea of concentration, sometimes you'll hear the words diluted and you'll hear the word concentrated, just in everyday vocabulary. And that doesn't really give us an idea of what that, what kind of solution we're really dealing with. If you dilute something, usually what you mean is you add more water to it. And that generally is true, although water isn't always the solvent that's being used. So when we talk about concentration, that is a measure of the number of solute particles. So remember, solute is what gets dissolved, the lesser amount of a substance in a solution. And the amount of solute particles within a certain volume of your solvent. Or sometimes we talk about the entire solution itself. And we'll look at the differences there between just the idea of how much solvent you have or the entire solution, because it does make a difference whether you're talking about just the solvent or the entire solution. So the general rule of thumb is that concentration equals the amount of solute. Again, remember, that's what gets dissolved in your solution, the lesser amount, divided by the amount of solution or just of the solvent. Now, why does that make a difference? If you're talking about the amount of solution, that's taking into account both the solute and the solvent all mixed together to give a certain total volume. If you're just talking about the solvent, then that excludes the solute in your calculation with your division. So there is a slight difference, and we'll look at some of those calculations that will become clearer. Now, in everyday grocery store shopping, you will often find products described by a percent by volume. So if you were to go to the grocery store and purchase vinegar or rubbing alcohol, or I should add in here hydrogen peroxide, because I think that's actually what I have a picture of. For hydrogen peroxide, you'll see a percentage on the label. This is not generally used as a marker in scientific research. When you're doing laboratory studies, you don't deal with the percent by volume. But I wanted to mention it because it's common enough that I don't want you to actually get confused now that we're going to learn the chemistry side of things, what things look like when you go into a grocery store. So a percent by volume just means the volume of the solute, what's ever being dissolved, into the total volume of solution. Now remember, a solution is solute plus solvent, so it's everything together. And then to get a percentage, of course, you divide by, or multiply, by 100. Now, here's what I mean by that. Let's look at these labels. If you can see this hydrogen peroxide label, I'll try to make it a little bit bigger. You'll see that it is 3% hydrogen peroxide. And you'll also notice that we have 32 fluid ounces, or if you want to go more, global markings as far as volume goes, 946 milliliters. So not quite a liter in this particular container. So what they're saying, let's go back up here to the definition over to this slide, that when you look at something like hydrogen peroxide, that 3%, we're saying this right here for that hydrogen peroxide, this right here, the percent by volume is 3%. So what that means is that your volume of solute divided by the volume of the total amount of solution gives you 3% hydrogen peroxide. So that entire solution, back to this bottle, is basically 97% water, 3% hydrogen peroxide. Likewise with your vinegar. If you have vinegar for cleaning or sometimes cooking at home, it's kind of on a slant in this picture, but you can see that says 5% acidity. So in this vinegar, again, the percent by volume is 5% of the actual vinegar, the actual acid. And then the rest of it really, again, is water for this case. So the volume of the solute, the volume of the vinegar divided by the total volume, which in this case, let's see if I can make that any bigger, 3.75 liters, so a gallon. 1 gallon or 3.75 liters would be down here, the volume of solution. And then the volume of solute, which means very little because it's only 5%. Do you understand what I'm saying? So 95% of this whole solution is water, and then 5% is acid. Now, but the reason I'm going through that, we're not really going to do any calculations on that because that's not really chemistry concentration markings. That's just more common everyday markings that you see on grocery store labels. What we're going to talk about today is molarity. Now, the reason you don't use molarity in everyday grocery store shopping is that most people don't deal with the idea of moles. But in chemistry, we do. We talk about moles. And so that's why we can use molarity. All right. So the definition of molarity is the moles of solute. Now remember, moles. Moles is important. And moles of the solute. So what gets dissolved. Compared to the entire volume of the solution. Okay. And you would mark this as, the way you would show this is you use a 6 and an italicized capital M. And in this particular case, we're talking about hydrochloric acid. So on a bottle of hydrochloric acid, if it's the concentration is 6 molar, you would see this notation of 6 molar HCl solution. Okay. Now we calculate this by taking the moles of solute, so in this case it would be HCl, and divide by the total volume of our solution. Now notice that these units matter. So molarity is moles of solute per liters of solution. So in your calculations, you have to make sure your numerator is converted to moles. So if you're given an amount in grams, you have to convert it to moles. And if you're given a volume in, say, milliliters, you're going to have to convert that to liters first. All right. So let's just dive right in. We're going to look at several examples of problems, different ways of phrasing. And then I will be posting, along with this video, you'll have some practice problems to do. All right, so here's the way a problem might read. What is the molarity of a solution that contains 3.40 moles of solute in 245 milliliters of solution? So go back to our formula down here. Moles of solute divided by liters of solution. So if you come back to our problem, you'll notice that, first of all, it's in 245 milliliters. So we have to do a conversion there. So that's my first step. Divide the number of moles. Excuse me, that should not say moles. Let's go. Divide the number of milliliters by the volume in liters. So basically, we got to convert. So 245 milliliters divided by 1,000. And that just gives you, move the decimal point 3 places over, 0.245 liters. Then we take the number of moles, which is already given to us in the problem, and to find our molarity, we say 3.4 moles divided by the total volume, which is 0.245. Okay. So our total solution there is 3.9 moles. Or excuse me, 3.9 molar solution. So we have a 13.9 molar solution, and we don't know what's being dissolved here. So we're just going to call it 13.9 molar is the way you would answer that question. Okay. Now, what if we went backwards? So we have a 0.6 liter solution It's 0.6 liters of a 0.5 molar HCl solution. How many moles of HCl does that solution contain? So let's go back again to our original equation. Molarity equals moles of solute per liter of solution. Now, in this particular problem, let me go back. Slightly different. We have a different unknown. We already know the molarity is 0.5. And we know the volume, 0.6 liters. So now, because we know that the molarity is 0.5 moles per liter, that's molarity, the definition, 0.5 moles per liter of solution, we can multiply our volume, and that will tell us how many moles of HCl we have. So in this particular case, with this concentration and this volume, we know that we have 0.3 moles of hydrochloric acid. Okay. Now, here's a situation. Let me correct that real quick. Here's a situation where we're given the number of moles of a substance. In this case, it's silver nitrate. I want to know how many milliliters of a 0.8 molar solution should be added to the reaction vessel to provide this amount. So let's read through this again. A chemical reaction requires 0.180 moles of silver nitrate. All right. Now I have a solution already made up that is 0.8 molar silver nitrate. So if I already have a solution and I know how many moles I need, 0.18, then I can use some manipulation to figure out this answer here. What volume? Basically, we're asking what volume in milliliters should I add to get this reaction going? I know I need 0.18 moles. So how do I do this? All right, 0.18 moles of silver nitrate. Okay. Now, because of my definition of molarity, I'm going to flip it because I have 0.8 moles of silver nitrate in 1 liter, and I started with moles. So if I take this and I divide by the molarity, I'm going to come out with a volume. So here, if I divide 0.18 moles by 0.8 moles, given to us because of the molarity, I will be left with liters. I'll be left with my volume. Now, the thing to keep in mind here is I don't want my answer left in liters. I want it in milliliters. So when I'm done with this calculation, I'm going to multiply, or I'm going to multiply that value by 1,000 to do my conversion. And when you do that, you get 225 milliliters of solution. All right. So there are various ways that I can go about giving you these answers, and you're going to have to be manipulating that molarity equals moles divided by liters of solutions. You just have to keep that in mind, that you have to have, in order to get molarity, you have to have moles per liters. And then from that, you can find, depending on what you already know, you can determine how many moles of a substance. And then you can figure out how many grams of a substance, because if you know the moles, you can convert to grams using the molar mass. Now, here's a situation where I still want to know the molarity. I want to know that capital M, and remembering that molarity equals moles per liter. I can use grams of NaCl to figure out moles of NaCl, and then I can divide by the volume. So you still have everything you need to know. It's just going to require an extra calculation. So here, the first thing I'm going to do, the easy calculation, milliliters. I don't want milliliters, I need liters. So I have to convert milliliters to liters. By doing that, I divide by 1,000 and get 0.650. Then I have to do another conversion because I need moles, but I don't have moles right now, I have grams. So I'm going to take the 63 grams of NaCl and divide it by the molar mass. That leaves me with moles of NaCl, and when I do that calculation, I get 1.08 moles of sodium chloride. Now I can go back to my original equation dividing moles per liter. So 1.08 divided by 0.65 gives me a molarity of 1.66. So you would say that is a 1.66 molar solution of NaCl. Okay. Lots of variety with problems here. So here's another one. This time, I need to know the mass I need. Sometimes you know what the outcome should be. You just have to know what to start with. So sometimes, like in this question, I said how many grams of solute, meaning I'm making a sulfuric acid solution, so H2SO4. How many grams of H2SO4 do I need in order to get 2 liters of a 3.5 molar concentration? So this is a few steps, but it's not hard steps. The calculations, it's just depending on the number of steps required. It's still just division and multiplication. But I can go and fill in what I already know. Now look at, this is nice because I gave you the volume in liters. So there's no conversion there. And you know the molarity, you know the concentration. And based on the last few problems, hopefully you're starting to memorize that formula. So molarity equals moles per volume in liters. So here we go. I'm going to fill in what I know. I know that the molarity is 3.50 molar. And then I know that the volume is 2 liters. I can cross multiply and figure out how many moles I have. When you do that, you get 7 moles. I'm going to need 7 moles of sulfuric acid, H2SO4. Okay, but then I'm not asking for moles, I'm asking for grams. So when I do that, I'm going to multiply the molar mass of sulfuric acid. Let me subscript these real quick. Sorry. I'm going to multiply the number of moles by the molar mass. And when I do that, I get 687 grams of sulfur H2SO4. That's how many grams I need to make a 3.5 molar solution with a volume of 2 liters. All right, we're going to actually stop there. I will do, the next thing we're going to look at is a dilution set, but we'll pick that up tomorrow. All right, so quick recap on today. Percent by volume, those are store items. I don't want you to confuse when you see store labels, percent by volume with molarity, because the normal population does not know about moles, or they've forgotten since they learned it in school. So when you see 3% hydrogen peroxide, that is not a molar value. They're basing it only on volume. So how much hydrogen peroxide volume per total volume within that container? Solute plus solvent, okay? But then we go to molarity, which is one of the ways in chemistry that we use to deal with concentration. If you will remember that the formula, here, is moles of solute, what gets dissolved, per liters of the total solution. If you will just remember that you have to have moles per liter, that will basically guide you in your problem solving, because you know that if you're given grams, you have to convert to moles. And if you're asked to find grams based on the molarity, you can get to moles and then convert using molar mass. So we're kind of pulling back from a few chapters ago and adding it to new information, just like we always do with chemistry. Okay, I'm going to stop sharing my PowerPoint and come back full screen for just a second. I think. Okay, so to wrap this up for today, I know you guys can do it. I'm posting practice problems. Meet me back in office hours or email me as you start to do these problems and you're not sure if you're getting the right answer. Email, remember, 8 to 3. I'll answer pretty quickly. Post in Google Classroom, talk to your friends, and then meet me back for office hours if you are confused about some of these problems. All right, I hope you guys are doing well. Still miss you. I'll talk to you later.